Today we will be studying the properties of polygons and solid figures. We'll consider all of the characteristics that are needed to create both polygons and solid figures. The first point that we need to review is what a polygon is. A polygon is a closed shape. It's also made up of straight line segments. So a polygon, we can see, is the three-sided triangle, a square. The rectangle is four-sided, it's a quadrilateral. We have a pentagon that is a five-sided polygon, and then a rhombus, which has all equal sides and is a closed figure. A polygon may not be an open shape. You can see that in the line below, we have one figure that is not closed, the fourth one over. A polygon may not have curved lines. So a heart, a circle, a rainbow shape, a curved arrow, none of these figures are polygons. A polygon is only a closed shape made of line segments. Another property of polygons is whether the polygon is convex or concave. A convex polygon will have vertices that point away or are on the outside of the figure. This is different than a concave polygon. In a concave polygon, at least one of the vertices will appear pushed in towards the interior of the figure. You can see the difference on the top line. There are examples of convex polygons, the triangle, square, rectangle, pentagon, and rhombus. Below you can see the polygons have a change in their shape. There's at least one vertice that moves in towards the center of the polygon. Young students in the past have suggested to me that this type of polygon, the concave polygon, forms a little cave in the perimeter of that shape. Another way in which we identify polygons is by the number of sides of the polygon. A polygon is made up of straight line segments. As you know, if there are three line segments, we will form a triangle. A square, a rectangle, and a rhombus are all made with four straight line segments, and these are called quadrilaterals. They're part of the quadrilateral family. Five sides, we create a pentagon. Six sides, and we would have a hexagon. 8 sides is an octagon. And 10 sides is a decagon. Another important part of a polygon is where the two line segments meet together. That will create a vertex. And when we have more than one vertex, they become vertices. As you can see, a triangle has 3 vertices. The vertices are shown by the star figure on that polygon. The rectangle, which is part of the quadrilateral family, has 4 vertices. You can see there's a star in each corner of the rectangle. That denotes the 4 vertices. The pentagon has 5 stars, and that shows where the line segments join together to create a vertex. And the pentagon has 5 vertices. The octagon has 8 vertices, and you can see each one is noted by the star shape, where the two line segments join together. To review, line segments that join together create a vertex. Polygons will have 3 or more vertices depending on the number of the sides for each polygon. Now let's shift our focus to solid figures. The solid figures in the top area, the light green area, are three-dimensional figures that have length, width, and height. You can see that these are the rectangular prism and the cube for our explanation purposes today. In the pink area, you'll see three-dimensional figures with curves. We have a sphere, the cylinder, and the cone. As you can see, all three of these figures have curved sides, so they have special properties that are different from our rectangular prism and the cube. When we first look at this slide, it appears very confusing. But if we take apart each of the details, we'll find that this really isn't very difficult to understand. So first, let's look at the faces of a solid figure that has edges. The faces are shown by the red arrows. You can see that not every face will have an arrow to it because there's faces that we cannot see in these figures. But the face is a plane shape, such as a square or a rectangle, or even a circle. And once we put together the plane shape, we put two pieces together, we create an edge. The edges are shown by the blue arrows. So on a solid figure, once you join together the squares, the rectangles, you'll find that you create an edge. The next part that's a little bit unusual is solid figures with curves. A solid figure with a curve will not create any edges. When you look at the ball, or the sphere as a math terminology, you'll see that it has no faces. There's no flat surface. However, the cylinder, which is in much of the same shape as a can, it will have two faces, but no edges. Likewise, a cone will have one face, but there will be no edges, just a point where all of the side portions come together. So once again, solid figures may have edges that are created by plane shapes, such as rectangles or triangles, circles or squares, even a trapezoid. And solid figures without edges may have one or two faces. If you work through these properties slowly and examine each of the solid figures carefully, it's really not nearly as difficult as it seems. Just for fun, let's try a change of pace and look at some things that maybe you have around your house. Sometimes when we're working with solid figures, it helps to use a manipulative. So I found this box, which will serve as a rectangular prism. When we're thinking about rectangular prisms, we will count the sides first. This box has 1, 2, 3, 4, 5, 6 sides. There are 6 sides in a rectangular prism. Next, let's think about the edges on this rectangular prism. An edge is formed when two flat surfaces or plane shapes connect together. So on this box, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 edges formed on this box. Now I think things get really interesting when we're thinking about a rectangular prism or a cube or a pyramid or a cone. These solid figures also have vertices. We saw the vertices where two line segments join together. Now we'll see that also is the same on solid figures. The point where two line segments meet is called a vertices. On the rectangular prism, you can see that I have 1, 2, 3, 4, 5, 6, 7 stars. And the same is true of the cube. You cannot see one of the vertex that is hidden in these figures. But on the rectangular prism and the cube, there are 8 vertices where two line segments meet. Now it's very interesting with the special vertex at the bottom. You'll see that on the cone and the pyramid shapes, there's one vertex. Not all of these figures have edges, but they do have a vertex where the points come together. The pyramid, you can see, is a four-sided pyramid. The cone has the curved area that meets at the top at the point. Just for fun, I threw in a pyramid from Egypt. And then there's a standard cone that you might see as you're driving down the street. And finally, who doesn't love an ice cream cone? And of course, the vertex of that cone is at the bottom. It's directly opposite the base, where you would find that delicious scoop of ice cream. So solid figures, look carefully, and you will find the vertex or the vertices of the solid figures. Let's do another just for fun. Finally, let's go back and review something that we're pretty familiar with, and that's line segments. When two line segments join together, it creates a vertex. On this box, there's several vertices. When you look at the bottom or the top of the box, you'll see 1, 2, 3, 4. You'll see 4 vertices on the top and 1, 2, 3, 4. 4 vertices on the bottom. So there's a total of 8 vertices on a rectangular prism. So to review, we have 6 sides. And we also have 12 edges and 8 vertices that you can see on a rectangular prism and also on a cube shape, which is made from sides that are all exactly the same size. And now, students, just when you thought that learning about vertices could not get better, I have a Just for Fun ×2 in store for you. Learning about vertices and the faces of solid figures gets even better. Hold on to your seats. We're ready to go for more. When I was looking for solid figures to share with you, I came across this 2-for-1 solid figure. On the base, you can see it's a cylinder. So there would be a face at the bottom and a face about 2/3 the way up, a circle face. And then there would be no edges around the center part where the cylinder is. But on the top, I first thought, oh, I found a cone. And the cone would rise up to one vertex. But when I looked more carefully, I found that that is actually a pyramid on top. And the pyramid, this one has 4 faces around to form the sides, but then it would also have a face at the bottom. So there would be 5 faces and 1 vertex. So at first, again, I thought it was a cylinder with a cone. And on further inspection, I found it was a cylinder with a pyramid. And now our final topic for today is a review of diagonals. As you learned earlier this year, a diagonal is created by connecting vertices inside of a figure. A triangle does not have any diagonals. It's impossible to create a diagonal because there is always a vertex that is next to another vertex. And the rule is that the vertices may not be next to each other. So a triangle is an impossibility to create diagonals. In our quadrilaterals, the square, the rectangle, and the rhombus, you can see that the vertices are connected opposite of each other. So there are two diagonals in each of these quadrilaterals. Moving to the pentagon, you can see that from each vertex, two lines extend to touch other vertices. And in this shape, you can see a star figure. The final shape that we have is a hexagon. It's a six-sided figure. And from each of the vertices, there are three lines that extend to connect to additional vertex points. So you must be very careful as you create your diagonals that you include all of them. And you might refresh your memory that sometimes using a variety of colors makes it easier to see that you've connected all of the diagonals. So for a quick review, I know this is a lot of writing. I know this is a lot of characteristics and traits and concepts to learn in one lesson. But again, this is mostly review for you. So first, a polygon is a closed shape that is made up of line segments, straight line segments. So that means that a polygon is not an open shape and it may not have any curved lines. A convex polygon has vertices that all point outward. All of the polygons above are convex polygons. A concave polygon has at least one vertex that appears to be pushed in towards the interior of the figure. And again, as my young students have suggested to me, it forms a little cave. And that's how they remember the difference between convex and concave. Polygons are named for the number of sides in each of the figures. A triangle with tri means 3. There are 3 sides in a triangle. Quadrilaterals. Quad means 4. So there's a variety of quadrilaterals. Squares, rectangles, rhombuses, trapezoids. Those would all be different types of quadrilaterals. Pent means 5, so pentagon is a 5-sided figure, and so on. A vertex is the point where 2 line segments meet. When you have more than one vertex, they are vertices. And we've studied each of these figures has a variety of vertices. Triangle 3, quadrilaterals 4, pentagon 5, hexagon 6, octagon 8, decagon 10. Moving on to solid figures, they are 3-dimensional with length and width and height. There's also special solid figures that have curved parts of their solid bodies. Flat surfaces on a solid figure, they are called faces. And flat surfaces that connect on solid figures create edges. There's a lot of information in this video, so I would suggest that you go back, you review. Some of the parts that are more difficult, look at them 2, 3, even 4 times. Study the parts that are difficult for you. And I would suggest that as you go forward in geometry, take your time, look at each of the traits like a detective. And I think if you look one by one, you will be very successful knowing the definitions and the vocabulary for geometry.